Okay, so the first thing you need to do is get students to draw up the axes of a graph on the edge of an A4 sheet of paper. Make it about half the size of the paper, and then draw in a demand curve from here to here, and dotted lines to cut at the axes of the graph. Then take a pair of scissors and cut along that demand curve line. Okay, so now you're left with a triangular piece of paper with the demand curve on it. The next step is to fold the paper so that each of the intercept points is folded back to the origin of the graph, like this. And fold along there. And then do the other one as well, so that essentially your folding process creates a rectangle like that. And then you can use a pen to mark the midpoint. So it's quite clear from this that this is the midpoint. Perpendicular from this point here to here is the midpoint of this axis, and then the same applies to this axis. So this is now the midpoint M of this axis, and since these are laid side to side, this is quite clearly the midpoint of the graph as well. So then what you can do is draw a dotted line down here to illustrate that. So at this price, this is adjacent to the midpoint, and this is perpendicularly above the midpoint on this graph here. Alright, so the marginal revenue curve is going to extend from here down to here. So this is now demand D equals AR, and this is MR here. The objective of this exercise is to try and explain why the marginal revenue curve in the earlier graph we drew cuts the axes halfway along here. What I've done is pasted that diagram onto one which shows the associated total revenue curve. The first thing we do is we go and we derive the average revenue curve algebraically. So that's given by the equation price equals A minus BQ, which is also, of course, both the demand curve and the average revenue curve. You can see when Q is 0, then price equals A. So when Q is 0, price is A. So A is the value of the intercept term, and B is the value of the slope. That slope there, dq, sorry, dp, dq. All right, now moving now down to the bottom graph, this shows you the way in which total revenue changes when you move down the demand curve. and it's a parabola, and you can show that it's a parabola by simply deriving the total revenue curve. And we know that total revenue is price times quantity. So if we take the price expression from up here, so price equals A minus BQ, and put A minus BQ in instead of price, multiply that by Q, we get the equation for the total revenue curve, which is equal to AQ, A times Q, minus BQ squared. Okay, so now the next task, this is the average revenue curve. The next task is to derive the marginal revenue curve, and we do that by simply recognizing that marginal revenue is the change in total revenue with respect to the change in output. And so we take the first derivative of this curve here, the total revenue curve or function, and we arrive at A minus 2BQ. Alright, so that is the expression for marginal revenue is equal to A minus 2BQ. Notice that the only difference between the marginal revenue curve and the average revenue curve is that this has twice the value of B. In other words, the slope of the marginal revenue curve is twice that of the average revenue curve. The A value is the same, so the marginal revenue starts in the same place, and the slope B is a constant in both cases, except that in this case it's twice what it was for the average revenue curve, so it has twice the slope. Now, why does it how do we show that it cuts, that the value of marginal revenue is 0 at this point? Well, we know that this value of on the demand curve, the midpoint, is where the total revenue curve reaches a maximum, namely at this level. And that's when the marginal revenue curve is tangent to the total revenue curve and is equal to 0. It's got no slope at all. We can see the slope by just following the line of this pencil as we go up the total revenue curve, and you can see it's flattening out. So it's always positive, but the slope is falling until it reaches a maximum of 0, and then it turns negative, and that's associated with points of the marginal revenue curve below this part of the graph, and the negative part. So now it's going down until it reaches this point here where quite clearly it's equal to 0.